Hello everyone, welcome to YourPedia. This is Chandrasekhar, Faculty of Electrical Engineering at YourPedia. We all know that CGPDTM, Controller General of Designs and Trademarking, has announced a good notification. So electrical engineering students are also eligible for their respective posts. So in this video, I'm going to discuss about power systems. Okay, this is one of the very important subject for electrical engineering. CGPDTM selection criteria is divided into two parts. One is first is prelims, second one is mains. In mains, see, our technical electrical engineering technical will be there in mains. In prelims, it is non-technical. So in mains, power systems is one of the very important subject. I'm going to take up some very good questions which are related to CGPDTM. So I selected questions in such a way that entire syllabus will be covered. That is the first criteria. Second criteria is all models will be covered. Okay, all models will be covered. And third is in one question multiple concepts will be covered. And fourth one is I can say by looking at the previous papers of CGPDTM, I selected these questions for giving you as an assignment. Okay, I'll explain you the basic procedure how to solve. So this kind of I can say assignments I will be giving further also. Okay, so this is the very first assignment in power systems. Let's enter into the subject. See, power systems is a vast subject. So basically we divide power systems this way: transmission, generation, transmission, distribution, all this comes under one part. Okay, so simply I can say that generation, distribution, transmission one part. Second part is analysis part, fault analysis, stability analysis and load flow studies. Third part is protection part. So if you look at the previous papers, good number of questions are appeared from, I can say, transmission part, especially from ABCD parameters. So for that some extension I am giving here, finding GMR, GMD, inductance, because ABCD parameters, if you want to find, you must have the knowledge of GMD, GMR, okay, and configurations of the conductors. All these things are required. So I am taking questions here, in this particular video such that all these will be covered. Okay, see, most of the questions will be from previous papers, I can say, are from transmission and protection, especially from circuit breakers, and stability analysis, and some questions are on I can say skin effect, corona, like this type of effects, right? So let me go with the very first question. The very first question is: a short three-phase transmission line has a series line impedance per phase of 20 plus J50 ohms. He is saying that it is a short transmission line which is having series impedance of 20 plus J50. The line delivers a load of 50 megawatt at 0.7 power factor lag. He given load values. What are those? 50 megawatt, 0.7 power factor lagging. Determine the regulation. You see, the question is about regulation. He given Z of the short transmission line. He mentioned it as short transmission line. Load values given. Determine the regulation of the line and the ABCD parameters of the line. If the same load is delivered at 0.7 power factor lead, determine the regulation of the line. System voltage is 220 kV. You see how many multiple things are added in this. You have to find ABCD parameters and voltage regulation of the transmission line. And what is the voltage regulation of transmission line formula? Yes, no load voltage magnitude minus full load voltage magnitude by, yes, full load voltage magnitude into 100 will give percentage voltage regulation, right? So this one, and you have to find ABCD parameters. This particular one given is a short transmission line. So the given load, you have to find a load, I can say load current first. IR is equal to, yes, S is equal to root 3 VL IL cos phi. Cos phi he mentioned, and voltage, load voltage is also mentioned. 220 kV. Some people may think that this 220 kV may be sending end voltage. See, always do remember one thing: given voltage is always receiving end voltage unless he specified. If he specified as sending end voltage, then only we take it as sending end voltage. Otherwise, always it is receiving end voltage. I have to find IR. So from that I have to find sending end voltage. Yes, what is voltage regulation formula? No load voltage. Yeah, this is voltage regulation formula. Here I am not going to solve it completely, just I will be giving you the idea. See, what is voltage regulation? Voltage regulation is equal to yes, V no load magnitude minus V full load magnitude, all these are magnitudes, by V full load into 100. percentage voltage regulation, please. Percentage voltage regulation. See, full load voltage is already mentioned by him, that is 220 kV. He given it. Then I have to find no load voltage. How to get no load voltage? We know one relationship, that is Vs is equal to AVR plus BIR, right? Under no load, this IR is equal to 0. Then this voltage will be VR0, which is nothing but, what is VR0? VR0 is no load receiving voltage. No load, yes, receiving end voltage. No load receiving end voltage. Find this VR0. If you want to find VR0, what we need? If you want to find VR0, you need, yes, this is the next question. In fact, yeah, let me add some pages here. Yes. Observe all of you. See, I am not going to solve it completely, just I am giving you the idea. So I need a VR0. VR0 is equal to Vs by A. VR0 is equal to Vs by A, right? So we are going to get no load receiving end voltage. See, for that, first of all, you have to find A, B, C, D parameters. So the same is asking. Find ABCD parameters. Yes. Find ABCD parameters. Yes. So he is asking us to find ABCD parameters. Observe here. Yeah, the line delivers. Determine the voltage regulation of the line, ABCD parameters of the line. If the system is delivered at 0.7 power factor lead, he is changing the power factor from how much it is? 0.7 power factor lag to 0.7 power factor lead, and then he is asking what will be the regulation. See, multiple things are covered in single question. First, find ABCD parameters of a short transmission line. You must know how to find ABCD parameters of a short transmission line, right? Then after that, find I can say no load voltage. Then after that, you find voltage regulation for 0.7 power factor lag, right? So after that, you change the power factor into 0.7 power factor lead, then you can do it. Okay, so this way we have to calculate, I can say, this problem. We have to solve this problem. Let's go to the next question. This question, yeah, this question, observe. This question is about finding inductance per kilometer per phase. If you want to find inductance, what is inductance formula? L per phase per kilometer is equal to S2 into 10 to the power minus 7 into ln of GMD by GMR. As it is a descriptive paper, suppose if this question is given for some good number of marks, some 20 marks suppose say, then you have to mention what is GMD, geometric mean distance. It is the effective distance over which mutual magnetic flux linkage will be calculated. What is GMR? It is the effective radius of the conductor over which self flux linkages are happening. Right? Now, what is the procedure to find GMD? Then you write it, find its GMD, find its GMR. Once you got GMD and GMR, then yes, see if you take here, there are three phases here: phase A, phase B, phase C, and phase A, phase B, and phase C. So between one phase to another phase, what we are finding, it is called as GMD. Between the same phase conductors, you see phase this A and A dash belongs to the same phase. Those are called as subconductors, bundle conductors. This is a bundle conductor system. So I taken a question here in such a way that it is going to have GMD, self GMD and GMR of a bundle conductor system. After finding that, you have to find inductance per phase. Observe it. See, one more thing I want to specify here, that is I am taking all these problems from a standard textbook. Okay, see, standard textbook. See, I can say one thing here, that is most of the descriptive examination questions are directly given from standard examination textbook. Suppose if you take engineering services examination, most of the questions are directly dumped from standard textbook. So always it's a thumb rule to practice from a good standard textbook for any subject, right? Yeah, observe here carefully. This 40 centimeters is the distance between subconductors, and he given distance between A to B, B to C, C to A, and this is unsymmetrical spacing. What is symmetrical spacing? If the distance between A to B, B to C, C to A is exactly equal, it is called as symmetrical spacing, but it is an unsymmetrical spacing. So here, first of all, what you have to do is find GMD. GMD of conductor A or phase A. GMD of phase A is what? Square root of. Why square root, sir? A is having two more phases in its vicinity, therefore square root you get. Square root of, yes, the distance between A to B, 6.5, A to C is 6.5 plus 6.5, it is 13. That is GMDA. In the same way, you find GMDB, square root of, yes, distance between B to A, B to C. It is under root of 6.5 into 6.5, that is 6.5 meters. See, one important thing to note here is, if you see, the bundle distance or subconductor distance is given 40 centimeters, and the radius also given by him as 5 centimeters, but the distance between one face to another face is given in meters. Look at those units, otherwise you will commit mistake. Okay, when you are finding inductance, yes, what is inductance formula? L is equal to 2 into 10 to the power of minus 7 into ln of GMD by GMR, Henry per meter it is. Okay, Henry per meter. If you want in kilometer, yes, you know how to do that. We multiply with 10 cube. Henry per meter, the formula is, see, L per phase is equal to, yes, 2 into 10 to the power of minus 7 into ln of GMD by GMR, Henry per meter is the formula. This is in Henry per meter. If you want per kilometer, see, per meter is this value, then multiply with 1000. But what my point here is, your GMD you will get in meters, GMR you are going to get in centimeters. Yes, why? Because, or see, in fact here I forgot to tell you one thing, that is this is I'll tell you here, as it is a bundle conductor system, I'll write the formula, I'll write that formula. As it is a bundle conductor system, yes, as it is a bundle conductor system, yes, I am writing inductance per phase is equal to 2 into 10 to the power of minus 7 into ln of, yes, GMD by self GMD. What is that? GMD by self GMD, Henry per meter. So your self GMD you are going to get in centimeters, convert that one into meters, or you convert this GMD from meters into centimeters. Both GMD and self GMD must be in same units, otherwise your answer will be wrong. See, Henry per meter. Now this way how to solve the question. You must know how to find GMD, self GMD, GMR. In GMR, while calculating inductance, you have to take R dash, not R. What is R dash? It is the effective radius of the conductor over which self magnetic flux linkage occurs, that is 0.7788 R. 0.7788 R, not the total radius you have to take. You have to take only 0.7788 R, not complete radius. But when you are calculating capacitance, you have to take the total radius, right? So yeah, so this way you have to do this problem. Let's go to the next problem. So this is also of this kind, but there is a difference. See, there are three phases here, phase A, phase B, phase C. This is a bundle conductor system. This is not like that. Read the question. Determine the inductance of a one-phase transmission line. Yeah, one-phase transmission line having the following arrangement of conductors. One circuit consists of 3 wires of 2 mm dia each, and other circuit 2 wires of 4 mm dia each. He is saying that this is one phase. See, some students will get confused. What does it mean by one phase? Single phase, he mean to say. Single phase system. Single phase 2 wire system. See, a 2 circuit system, or not 2 circuit, 2 wire only. So this total is 1 wire according to him. This total is another wire. See, A and B he mentioned. See, one circuit consists of 3 wires. This is one circuit, this is another circuit. So this is a single phase. See, all these 3 are forward wires, these 2 are return wires, right? So you have to find what is asking, find the inductance of single phase. This is single phase transmission, this is forward wire, these 3 are forward, these 2 are return. Okay, you can take that way. Circuit A is forward circuit, forward wires, circuit B is return wires. Now you tell me, see, I can say like this, from here I can say this one as 1A or 1, 2, 3. This is 4, 5 I'll take. 1, 2, 3 belong to circuit A, 4, 5 belongs to circuit B. So A is of one circuit. A means 1 to 2, 2 to 3, or 3 to 2, 3 to 1, all these are self. I repeat, see, one with itself, comma, see, these are the self GMDs we are going to get. 1 with itself, I can say 1 with itself into 1 with 2, next 1 with 3. How many I have? Cube root. So this is self GMD of 1. This is self GMD of conductor 1. In the same way, self GMD of conductor 2. Self GMD of conductor 2 is, yes, 2 is 2 itself, 2 with 1, 2 with 3. Cube root it is, because I have 3 distances. In that way, you have to calculate self GMD of 1, 2, 3, then circuit A itself is having 3 self GMDs, therefore it is cube root of self GMD of 1 into self GMD of 2 into self GMD of 3, then you are going to get self GMD of circuit 1. In that way, circuit B also. Again, 1 with 4 is GMD, not self GMD. 1 with 5, again it is GMD, not self GMD. 2 with 4, 2 with 5, 3 with 5, 3 with 4. After that, you have to calculate the total GMD. This way you have to proceed for calculating this circuit inductance. See, again I am telling you, people may get confused in the examination by looking at the terminology. In engineering, especially in the subjects like power system, terminology is important. Why? Because we have to understand what exactly he given. If we don't understand what exactly given, we will commit mistake by assuming something else what it did not meant for, right? Let's go to the next question. Yeah, this is also one of the good question. Yeah, what is saying? Determine the efficiency and regulation of a, see, in this question is asking us to find both efficiency and regulation. Determine the efficiency and regulation of a 3-phase 100 km 50 Hz transmission line delivering 20 megawatt at a power factor of 0.8 lagging and 66 kV to a balanced load. He given complete load story. Load is of 66 kV. This is receiving an voltage. I told you, always unless mentioned, it is taken the given voltage as receiving an voltage, right? And 100 km 50 Hz 20 megawatt power factor is 0.8. Yeah, the conductors are of copper, each having resistance of 0.1 ohm per kilometer. Okay, so per kilometer resistance is 0.1, means then for 100 kilometers how much it is? 100 into 0.1, it is of 10 ohm. Yes, comma 1.5 centimeters outside dia and spaced equilaterally 2 meters between conductors. Neglect leakage and use nominal T and a nominal pi method. This is leakage, not leakage, it is leakage. Okay, this is leakage. So you know, he did not given inductance, he given conductor configuration. There are 2 conductors. He is saying that, yes, how many? Yeah, equilaterally the conductors are of copper, each having resistance of 0.1 ohm per kilometer, 1.5 centimeter outside dia, spaced equilaterally 2 meters between centers. Yeah, this is 3-phase, phase A. Yeah, this is phase B and this is phase C. Equilaterally means this distance and this distance are same, right? Equilaterally spaced. Then what is that distance? What is the distance? How much he given? 2 meters. This is 2 meters. This is C. This is 2 meters. This is 2 meters. This is 2 meters. Now, by using this one, you have to find inductance per phase. Inductance per phase and capacitance per phase also we have to calculate. Then he is asking us to take nominal T one time and nominal pi method one time. Yes, and by taking all this, he is asking us to find regulation and efficiency. If you want to find regulation and efficiency, one must have ABCD parameters. Yes, this is a T model. Sorry, this is a nominal T model or general T model, right? And another pi model. You know how pi model looks. Pi model is this one. This is a pi model, right? Find the ABCD parameters. Once you got the ABCD parameters, use those ABCD parameters for finding regulation and voltage regulation and efficiency. In this problem, if you see in the last problem, all the things covered: finding GMD, GMR, okay, from that finding inductance, capacitance, resistance. Okay, not resistance is nowhere linked with GMD and GMR. Resistance. After this finding ABCD parameters, after this finding voltage regulation and efficiency. You see, if you solve this problem entire, I can say almost a transmission part, that is see, transmission is a very big thing. In transmission, I can say like finding performance of the line and I can say ABCD constants of the line is done. Okay, see, mostly this performance of transmission lines, ABCD constants and I can say finding voltage regulation and efficiency is covered by just solving this problem. Okay, so this way further also I will be providing you with the assignments and ideas how to solve those assignments. Thank you.